This video looks at building stratigraphic relationships from a map, and we'll be using this classic area in the Northwest Highlands. This is the map we'll be using, which shows different rock types, their boundaries, and, critically, the orientations of bedding in those units. From field investigations, we know that the Cambrian strata, that's those rocks over on the right-hand side of the map, are conformable, and there are two unconformities on the map. One between the Cambrian strata and the underlying Torridon group sedimentary rocks, and then between the Torridon group and the underlying Lewisian gneisses. We'll use that information in the cross-section, and we'll also want to understand the stratigraphic thicknesses of the units. So we'll be drawing a cross-section, and we'll be looking at a generalized vertical section, both products coming from the map. So here's the map, and we're going to try and draw a cross-section through the map to show the stratigraphic relationships. We'll use a ruler, some colours that match the stratigraphy, some normal pencils and a protractor, together with map strips to take measurements from the map to the profile. So let's get going. So the first thing to do is to draw a line of section, and we're going to do that down Loch Assynt itself. We'll put a measuring point in here so we know where we're measuring from when we take information from here onto our profile, and we'll draw the profile line onto our paper here like that and mark the reference point. So the next challenge is to take the geology from the coast and project it onto this profile direction. And we're going to start down here because we're closest to the profile, so the extrapolation is the smallest we'll need to do. I'm going to extrapolate along the orientation of strike here because the boundary would track out across the horizontal surface of the loch side along its strike, like that. So that's where it intersects the line of section, and that's where Durness limestone and Saltarella grit meet. So now we're going to take that point and put it onto our profile. So we take a measuring strip, just the right length, find the point here, which is our reference point, over to where this boundary is, just there, take that measurement and transfer it across to here onto our profile. And I'll just add some colour so we know what we're doing. This side of it is Saltarella grit. Sorry, this side of it's Durness limestone. This side is Saltarella grit. Now let's continue, and we can put the base of the Saltarella grit in now. So here it is at the side of the loch, and we can project it along its strike to here, and it projects more or less parallel to the boundary of the Saltarella grit and limestone. So that's where that point, fucoid bed Saltarella, intersects the profile. We can do the same with the pipe rock, take it out along its trend, so that gives an outcrop width to the fucoid beds. Do the same with the pipe rock, lower quartzite boundary. It's going to come along like that, so that's where it intersects the profile. And then finally the base of the lower quartzite, which is going to come along to here, to that position there. So there's an increasing uncertainty as we come this way in terms of where these points are, because the extrapolation in each case is getting longer and longer, but we can just live with that. The next thing, of course, is to transfer this information onto our profile. So we put the map strip back onto the profile, line it all up again, just to confirm. There's our reference point, there's the base of the Durness limestone, so that is the base of the lower quartzite. That is the base of the pipe rock, that's the base of the fucoid beds, that's the base of the Saltarella grit, that's the base of the Durness limestone, which we've got already. Take that information, transfer it across. So here we go, line it up with a reference point. That matches where we had it before, the Saltarella grit Durness limestone boundary. There's the lower quartzite base, there's the pipe rock base, there's the fucoid bed base, there's the Saltarella grit base. Let's put some colours on. So we can colour that all in the Saltarella grit. that all in as fucoid beds. That's all in as pipe rock in the light blue, and then this is all the lower quartzite on the profile, and then I'll just put a bit of colour over here to represent the toroidal group that underlies the lower quartzite. So that's collected the geology along the level of the profile. Now we need to extrapolate above and below ground. For that we need to have some information about the orientation of these materials in here, these rocks, and we can use the dips that we've got in the stratigraphy through here, because we've established that all these units are conformable. I'm going to make this simple by just picking one single value for the dip, and let's just pick 12 degrees, dipping this way, so the cross section is drawn in the dip direction. We can directly take the dips and transfer them onto our profile. So we'll take a single value of 12 degrees. Okay, so put a protractor. Let's start off here on the base of the lower quartzite, line it up, put it on at 12 degrees is there, and just join that up, shall we? There we go. It's one of the rare occasions I'll use a ruler on a profile like this, because we're assuming the rocks are retaining perfectly planar orientations. We've done that for the base of the lower quartzite. Let's put on the top. Of course, this should generate a parallel line. Here we are. Assess that. Yeah, it's pretty parallel. Let's go to the top of the pipe rock. 12 degrees there. Running out of paper, so I'll just eyeball these in to be parallel. Just look at that, that's not too bad. So there we have the projection of the geology above and below ground. Okay, let's just colour it in. Let's put the quartzite in. Here's up and above ground. Below ground, put the pipe rock in. Let's put the fucoid beds. The centre of the grit and the very base of the Dennis limestone there. I'm just going to bring out the boundaries a little bit in here so we can see them against the colour a bit better, like this. There we go. And I'll add bedding into this to show and emphasize the fact that bedding is parallel to these boundaries. Okay, so that's relatively straightforward. The next thing is, how do we put the base of the Torridonian against Lewisian onto our profile? That contact is irregular. It goes out of the water, crosses the road, comes back down to the water again, and then comes back out of the water. So unlike these boundaries, which are planar and simply dipping towards the east-southeast, this boundary must undulate. That means the projection onto the profile carries an uncertainty. We don't quite know what the trend of these undulations might be. So this is necessarily going to be slightly more uncertain. But I'm just going to suggest that these undulations trend in this sort of shape through here, so we can just project them in like this. It'll get an idea of the scale, certainly. So again, I'm starting a new map strip. Let's line that reference point up to here. That bit there is Torridonian, that bit is Lewisian, that bit is Lewisian, that bit is Torridonian. So now I'm going to take that information onto our profile. but I didn't mark. Top tip, yes I did. That is the reference point. So I line that up with the reference point. Lewisian, Torridonian, Lewisian, Torridonian. Let's now add the colour. Just make sure we got that. That bit is Lewisian. That bit is Lewisian. Through there. And the remaining portions in here are Torridonian. The contact comes out from below the water level, up, not very far, down again, and just roller coasters along. So the boundary is just cutting in and out of the water level. So where does it go here? It never comes up to the side of the loch through here at all, so it's always below loch level under here, and presumably is only just below the water level. If we look in this part, the boundary is just simply running along between 80 and 100 meters, just almost parallel to the road through there, so flat lying-ish. And under here, the beds above are dipping, what, 4 degrees, 2 degrees, 6 degrees, that's really low angle. So if we use these bed orientations as a guide, presumably the unconformity is just below surface. I'll do that. I won't draw it as a straight line, I'll keep it fairly irregular, arbitrarily drawing in some undulations to honour this sort of geometry. And it's going to come along and has to abut here the unconformity at the base of the lower quartzite. We can sort of see why if we start drawing in the Torridon dips in here. These are just trends of bedding, just gently dipping, if at all, through here. This would all be Torridon group rocks coming up, and they must abut the unconformity, which I'll just draw in here, the planar unconformity at the base of the lower quartzite. So if these rocks abut the unconformity, so too must be the underlying basement to them, so the Lewisian must abut the unconformity from here going down. So let's just colour that in. Lewisian down here, so at depth Lewisian will lie against Cambrian strata, but over here it's separated from the Cambrian by the overlying Torridonian strata. Just tidy that up a little bit. Let's just put the Torridonian in. Lightly, so you can still see the bedding underneath. I'll just emphasise the fact that the quartzites overstep the Torridonian by just extending them a bit further up into the sky and putting some more bedding in here, just so we can really emphasise the fact that this package is discordant to this, like that. Almost done. Just a bit of housekeeping first. Let's put the scale on. We've got the scale up here, so I'll take a map strip just to make sure we're doing it right. That's that end of the scale bar, that's the other. Take that across here, put it down. That's why I'll put it up in the sky, so up here. The scale bar's 500 meters, so that's 500 meters. We've honoured the same dips between the two, so we haven't tilted anything, so the vertical exaggeration is 0, so vertical and horizontal scales are automatically the same. We now to orient it west northwest to east southeast. Let's label some of the things here. I'm going to say this is the sub-Torridonian unconformity, brackets irregular. This is the sub-Cambrian unconformity, planar. We can then do this, we can say formable succession. Okay, and we can capture therefore and annotate the relationships. Finally, just a title section showing stratigraphic relationships, north side block Assynt. If these are two distinct pieces of paper, it's worth just adding the key or just labeling things. So we can say this is Lewisian, this is Torridon group, lower quartzite, pipe rock, fucoid beds, Saltarella grit, Durness limestone, just so we know what the units are. So now let's use the map to draw a generalised vertical section. Well, let's be clear at the outset, the only units that the thicknesses will matter are the lower quartzite, pipe rock, fucoid beds and Saltarella grit. We don't see the top of the limestone, and the Torridon group has got variable thickness because it's cut out progressively by the subcambrian unconformity. So the calculations we're going to make relate to lower quartzite, pipe rock, fucoid beds and Saltarella. We can use the outcrop width from the profile construction that we've done already. So the outcrop width for the lower quartzite is this distance here between its base and its top on a horizontal surface, in other words the water, and it's measured in a direction perpendicular to the strike, which happens to be the profile line of our cross section. So that's the outcrop width of the lower quartzite. That's the outcrop width of the pipe rock, that's the outcrop width of the fucoid beds, and that there is the outcrop width of the Saltarella grit. 1, 2, 3, 4 measurements we can make. We can see now qualitatively that lower quartzite and pipe rock should give rather similar values for their thickness because their outcrop widths are the same. The fucoid beds will be slightly less than a half that of the pipe rock. The Saltarella grit will be slightly less again than the fucoid bed. So we have a qualitative check on our calculations that we'll make in a minute. So what are these outcrop widths? Well, I'm just going to see what the scale here is. And if I line up my ruler with this, I can see that 500 meters is 5 centimeters on my ruler. So therefore 100 meters is a centimeter. A millimeter is 10 meters. So we can use that directly to make some simple measurements here to get real outcrop widths. So let's do that. The width of the lower quartzite there is going to be 440 meters. The width of the pipe rock here, 400 meters. The width of the fucoid beds, 150, put it there so we can see it. Width of the Saltarella grit is 110 meters, converting the scale from here via the ruler to the map. Okay, so how are we going to use that information, the outcrop width, to calculate the true thickness of the units? Well, let's just sketch up some simple trigonometry setup. So here is a unit with its top and base. Here is a, just extend it, here is a horizontal line through that. Well, this is a profile. That is the outcrop width measured horizontally. I'll label that W. The true thickness is the distance measured perpendicular to the boundaries. So that's the true thickness, the value we want to get. And they're related via this angle here, the dip, simply by the expression that T is going to be equal to the outcrop width times the sine of the dip. So what's the dip? Well, the value we've used is 12 degrees. So alpha equals 12 degrees. The sine of 12 degrees is 0.208. Well, let's just call that 0.2. Then we just have to have these values by a fifth which makes things simple, doesn't it? So a fifth of that is 85 meters. This value here will be 80 meters. That'll be 30 meters, and this will be 22 meters. So now we can take these values and draw a generalized vertical section. Okay, we'll do this on a new piece of paper. So here we go. Let's put up a vertical side to this. Okay, so we're going to use 85 meters. I'll call that, we'll put a base to that. 85 meters, we'll call that 85 millimeters. For the top of the lower quartzite, we've got 80 meters to the top of the pipe rock. We've got 30 meters top of the fucoid beds, 22 meters a bit further to the top of the Saltarella grit, and I'll just extend that out. That's the top of the limestone. So let's just quickly sort that out. So we have a column. Just bring these across. That's the top of the Saltarella, base of the Saltarella, base of the fucoids, base of the pipe rock, base of the lower quartzite. We'll put the Torridonian in like this. So the Torridonian truncates against the base of the lower quartzite. There we go. Lower quartzite, let's just write the numbers down. That's 85 meters. That's pipe rock, 80 meters. Fucoid beds, 30 meters. Saltarella grit, 22 meters. Durness limestone. Let's just colour this in. So we put some Lewisian, the Torridonian, like that. I'll just quickly scruff this in. The lower quartzite, the pipe rock, the fucoid beds, Saltarella grit, and the Durness limestone. Just put the scale on here, 1 centimetre on the section. Is 10 meters of rock, and there is our generalized vertical section. Torridonian, Lewisian. So these are the products we've generated through this short study. We have a map here now annotated with the projection of the boundaries out into Loch Assynt, projected along the direction of strike. We've used those to intercept a line of cross-section running along the loch, and that in turn has been used to build the cross-section. We show on the cross-section the conformable strata in the Cambrian that lie in turn unconformably upon the Torridonian, and that lies in turn unconformably on the Lewisian. The unconformity between Torridonian and Lewisian is truncated by the subcambrian unconformity. We can measure directly the outcrop widths as projected out across the loch. The outcrop widths plus some simple trigonometry, in this case the sine of the dip of the strata multiplied by the outcrop width, gives us the true stratigraphic thickness. We've done that for each of the Cambrian units in turn, the lower quartzite, the pipe rock, the fucoid beds and the Saltarella grit, and we've stacked those one on top of the other in the correct order to draw a scaled, generalized vertical section. The section continues up to an indeterminate amount of Durness limestone. It sits on a planar unconformity against Torridonian and Lewisian rocks, that are discordant to that planar subcambrian unconformity. We cannot work out the thickness of the Torridonian because it's wedge-shaped and doesn't have a single value, and we don't see the top of the Durness limestone. So we only give figures for the thicknesses of the stratigraphic units we've been able to calculate. So that's that exercise.